Welcome to This Explainer. Today, we're diving straight into how a fascinating system called Nemori is literally curing AI amnesia, and it's doing it by borrowing blueprints directly from human cognitive science. Look, if you've ever chatted with a large language model and realized it's treating you like a total stranger every time you start a new session, well, you've experienced this amnesia firsthand. It's frustrating, right? But today, we're going to see how Nemori actually solves this by teaching artificial intelligence to organize its memory exactly the way you and I do. So let's just get right to the heart of the problem. Why does your AI forget your past chats? Basically, it's because it processes your highly dynamic life as just one long, flat, arbitrary stream of text. Traditional AI systems are totally constrained by their context windows. As the chat gets longer, the math gets overwhelmingly complex for the model. And they end up suffering from this well-known phenomenon called lost in the middle, where they literally just forget the information that's buried in the center of long conversations. They don't have a structured way to recall past interactions, so your entire history just blurts out into one endless, overflowing document. So here's our agenda for today's explainer. First, the AI amnesia problem. Then, organizing experiences, followed by two-step alignment. After that, we'll hit the free energy principle, and finally, creating episodes. All right, kicking things off with Section 1, the AI amnesia problem and the flaws in current memory. To give AI a memory, developers up until now have mostly relied on a framework called RAG, which stands for Retrieval Augmented Generation. But here's the catch. RAG was built for static documents, not flowing back-and-forth dialogues. Standard RAG simply chops up conversational data based on totally arbitrary token limits, literally just word counts. It's kind of like taking a pair of scissors to a book and cutting it every 500 words, no matter if you're in the middle of a sentence or a really important scene. But the human mind, we definitely don't do that. We naturally organize our lived experiences into meaningful contextual events. Which brings us to Section 2, organizing experiences and defining natural events. This is where things get really cool. Nemori draws its inspiration directly from event segmentation theory. This is a foundational concept in human psychology, the idea that our brains naturally divide the continuous, never-ending flow of time into distinct, meaningful events with clear boundaries. So instead of just blindly counting arbitrary words, Nemori actually teaches the AI to autonomously draw boundaries around topics. It uses the AI's own reasoning power to monitor a conversation, watch for shifts in intent or topic, and define a natural episode. Ultimately, for you as the user, this means the AI stops awkwardly interrupting its own train of thought just because it hits some invisible word limit. This visual perfectly captures the difference. Notice how standard RAG awkwardly cuts this conversation about an apple right in half. The user asks, "What color is apple?" The AI answers, "It is red." The user says, "Yes, I love it," and boom. RAG chops the memory block right there. It literally separates the AI's final thought, "It is very healthy," into a completely disconnected chunk of memory. It makes no sense. But look at the episodic method used by Nemori. It correctly groups that entire semantic interaction into one coherent block. It actually waits until the user says good morning, which is an obvious shift in topic, to draw the boundary. Moving right along to Section 3, two-step alignment, and how we translate that psychology into actual computational logic. To pull this off, Nemori uses what's called a two-step alignment principle, and it is incredibly elegant. Step 1 is boundary alignment. This is where the system actively buffers your messages and uses an intelligent detector to flag when the conversation naturally shifts, like if you change the subject or make a new decision. Once it triggers that boundary, we hit Step 2, representation alignment. Now, instead of just saving a raw, messy chat log, Nemori simulates human storytelling. It generates a concise title and a really rich third-person narrative of that specific event. What's absolutely fascinating here is seeing how cleanly the input chunking problem maps directly to our cognitive principles and then all the way down to specific computational modules. On the left, you've got the input chunks problem, which is solved by boundary alignment, and that computationally translates to topic segmentation. Then in the middle, the representational alignment principle becomes episodic memory generation. We are literally hardwiring psychological principles directly into the architecture of the code. All right, Section 4, the free energy principle and proactive AI learning. Okay, so to move beyond just passively storing a bunch of summaries, Nemori relies on a really fascinating cognitive concept known as the free energy principle. This principle dictates that true learning happens when an intelligence attempts a task, notices a surprising error, and then updates its understanding. Just think about how we learn best as humans, right? You try to solve a math problem, you realize where you went wrong, and that little moment of surprise or that prediction gap is what actually cements the new rule into your semantic memory. Nemori applies this exact same proactive learning mechanism to the AI. And that brings us to our final section, Section 5, Creating Episodes and the Learning Cycle. So Nemori puts that free energy principle to work through a 3-stage cycle. When a new episode is created, it doesn't just file it away in a folder somewhere. First, prediction. Nemori looks at the new episode's title, checks its existing long-term memory, and literally tries to forecast what happened in the conversation. Second is calibration. It compares its own guess against the raw, unedited conversation to find the gap, the surprising, novel information it didn't predict. And third, integration. It distills that surprise into new semantic knowledge statements and actually updates its brain. You can see this entire flow right here. Notice how the semantic knowledge distiller acts as the brain's calibration engine. It is actively building a world model from its own predictive mistakes. This is a massive leap forward for AI. Instead of just passively running a summarization rule over an old, dead chat log, the system is proactively testing its worldview against reality and evolving its semantic database with only the freshest, most necessary facts. Because it uses this complementary system of raw episodic context paired with pre-reasoned semantic facts, Nemori achieves something called reasoning during memory formation. Let me give you a great example from the source data. Imagine an AI is asked, when did John receive mentorship? Standard systems completely hallucinate or get confused if the chat log just says, John got mentored yesterday, because they lose track of when yesterday actually was. But Nemori? It already noticed that event during the predict calibrate cycle, reasoned out the exact date in the background, and stored a crystal clear semantic fact. John was mentored on June 15th. It transforms complex, error-prone logical reasoning into simple, lightning-fast fact retrieval. And the computational proof of this approach, it's honestly stunning. By organizing memory like a human, breaking it into semantic episodes, and proactively learning from surprise, Nemori absolutely crushes benchmark performance. But here's the real kicker. It does this while using 88% fewer tokens than systems that try to process the full context. It takes significantly less computational power because it isn't constantly rereading an entire endless textbook of raw data. It's just recalling a finely tuned, highly organized memory. Ultimately, this means we get an AI that is faster, smarter, and significantly cheaper to run. I want to leave you with this provocative thought. As we continue to architect machine memory based on our own cognitive science, we aren't just making AI more efficient or more affordable. By giving it the ability to segment experiences naturally and the capacity to literally be surprised by new information to update its worldview, we're making it fundamentally more relatable. Think about it. If an AI remembers your life the exact same way you do, what becomes possible next? Thanks for joining me on this explainer, and definitely keep your eyes on how these cognitive blueprints continue to shape the future of machine intelligence.